Okay. An unsymmetrical pre-stressed concrete has top flange 500 by 200 mm, bottom flange 400 by 300 mm. Web size it is given 200 by 800 mm. It is supported over span of 15 meters. First of all, you do the cross section of beam. So top flange it is given. Top flange it is given 500 by 200 mm. Okay. So top flange it is given 500 by 200 mm. Just draw this sketch. 500 by 200 mm. Then web size it is given 200 by 800 mm. Web size it is given 200 by 800 mm. So actually this section it is unsymmetrical. Okay. Actually this section it is unsymmetrical, and bottom flange it is given 400 by 300. So top flange it is, just give the dimension 500 by 200 mm. 500 by 200 mm. Then wave size it is given 400 by 300 mm. 400 by wave size it is given 400 by 300 mm. Sorry, wave size it is given 200 by 800 mm. Wave size it is given 200 by 800 mm. So wave size it is given 200 by 800 mm. So width it is 200 mm. Okay, width it is 200 mm, and depth of this wave it is given how much? 800 mm. Okay, so depth of this beam it is given 800 mm. Okay, this is wave size. Okay, and bottom flange dimension it is given 400 by 300 mm. Okay, bottom flange it is given 400 by 300 mm. It is 400 bottom flange, and depth it is given 300 mm. So this one it is bottom flange. So it is 400 width, and depth it is given 300 mm. So first of all, we find out the cross-sectional area of this unsymmetrical I section. So first of all, you calculate cross-sectional area of this beam. So first it is 500 by top flange size it is 500 by 200 mm. Then plus wave size it is given 200 by 800 mm. 200 by 800 mm. Then plus wave size it is given bottom wave size it is given 400 by 300 mm. We'll get the cross-sectional area of beam. Tell me how much cross-sectional area of this beam. Capital A is equal to, just do the calculation, 500 into 200 plus 200 into 800, then plus 400 into 300. So how much this one? 80 into 10 raised to 3. Am I correct, student? 380 into, am I audible, everyone?
Yes, sir.
Okay. 380 into 10 raised to 3, 10 raised to 3 mm square. Okay. Everyone know what same answer? So second thing, you calculate the y bar. Y bar. Second thing, you calculate the y bar. How you calculate y bar? From bottom side. We'll take it is from bottom side, because this one it is unsymmetrical section. That's why we need to find out the YB. How you can calculate YB, student? Anybody know formula? A1 Y1 plus A2 Y2, then plus A3 and Y3 divided by A1 plus A2 plus A3. This one it is phi 1. This one it is CG formula. Okay, A3. So just put all this value here. So A1 it is how much? A1 it is, we divide this section, it is in 3 parts. Okay, first we take the bottom flange, it is 1, this web it is 2, and this top flange it is 3. Okay, third part. Okay, just find out y bar for that. Okay, so y bar is equal to y bar is equal to y bar is equal to y bar is equal to, so A1 it is 400 into 300, y1 it is 300 by 2, it is 150, then plus wave size, then wave size it is 200 into 800 into y2. How much y2, student? Y2, anybody know how much y2? Y2 it is 300 plus 800 divided by 2. 300 plus 800 divided by 2 means it is 400. So it is 700. Am I correct? It is 700 mm. Then plus A3y3. A3y3 means top flange 500 into 200. 500 into 200 into y3. Y3 how much? 300 plus 800 plus 200 divided by 2. So it will be 1200 mm. 1200 mm. 1200 mm. Student, are you getting point? This how we have calculated? We'll write once again. Just see here. Y1 it is 400 into 300 into y1 it is 150 mm, then plus 200 into 800 into y2 it is 300 plus 400 it is 700, then plus A3 it is 500 into 200 into 800 plus 300 1100, it is 1200. Okay, this one it is 1200. Anybody have doubt here, student? This one it is A11. Now divided by A1 plus A2 plus A3 means it is 400 into 300 plus 200 into 800 plus 500 into 200. Okay, now tell me y bar how much. Just do the calculation. 400 into 300 into 150 plus 800 200 into 800 into 700 plus A3y3 500 into 200 into 1200 divided by 400 into 300 plus 200 into 800 plus 500 into 200. So it is 657.89. Correct? So y bar is equal to 657.89. So then what same answer? We'll write here this one. Y bar is equal to 657.89 mm. Student, we got same answer. Okay. So next, find out the CG of beam. Sorry, moment of inertia of beam. Okay. So I is equal to by law of parallelogram. Here we apply the law of parallelogram. Ixx1 plus Ixx2 plus Ixx3. Okay. So here we apply the law of parallelogram. Ig plus here AH square. Ig plus AH square. Ig plus AH square. Means this one you can apply here. Okay. Ig plus AH square. So now you apply the law of parallelogram here. So first Ixx1 400 into 300 cube divided by 12. 400 into 300 cube divided by 12. 300 cube divided by 12 divided by 12 divided by 12 plus AH square. Okay. A1 H square means 400 into 400 into 400 into 300. So H square means y bar minus y1 square. Square means y bar minus y1 square. So how much y bar? Y bar it is 657.89. 657.89. 657.89 y bar, and y1 how much? Y1 it is 150 square. 150 y1. Okay. Bracket square. So this one Ixx1. Okay. This one it is Ixx1. So now plus Ixx2 is this one wave. So here B it is 200. Then depth it is 800. Okay. 200 into 800 cube divided by 12. 200 into 800 cube divided by 12. 200 into 800 cube divided by 12. Then plus 200 into 800. Area of this wave it is 200 into 800. 200 into 800. 200 into 800. Then H square means y bar minus y2 square. Y bar minus y2 square. So 657.89. 657.89. 0.89 minus y2. So y2 300 plus 400, that is 700 square. If this get my minus value, it will be get automatically plus because of square. Okay, because of square. Okay, then plus third value, it is top flange, width it is B 500 into depth it is 200. 200 cube divided by 12. 200 cube divided by 12. 200 cube divided by 12 divided by 12 plus A3 500 into 200. 500 into 500 into 200. 500 into 200. So y bar it is y bar minus y3 square. So 657.89. 657.89 1.89. It is 1.89. So y3 it is how much? Y3 student? 300 plus 800. It is 1100. 200 divided by 2, 1200. 1200. Are you getting my point, student? How you get y3 value? See, this we are measure from bottom. Okay. So 300 plus 800 divided by 200 divided by 2. It will get 1200. Okay. Now tell me how much moment of inertia. So I is equal to anybody ever done calculation? 7.04 into 10 cap 10 mm raised to 4. Okay. You know what same answer, student? Anybody have done calculation? Please keep respond. Ashwari Kumbar, have you done the calculation?
Sir, doing.
Okay. So now find out the section modulus. So here we got the two different sections, Z bottom and Z top. Okay. I is equal to, we have calculated I is equal to 7.04 into 10 cap mm raised to 4. You got this. Okay. So now find out first of all Z bottom, or otherwise you can write ZB. ZB is equal to I by YB. I by YB. Okay. I by YB. Okay. So CG from the bottom side. YB means CG from the bottom side. So we are calculating this one. It is YB. Okay. YB means how much this one? So this one it is 7.04 into 10 raised to 10 divided by y bar it is how much? From bottom side this one. Okay, 657.89 will get ZB. Will get the ZB. Tell me how much section modulus from the bottom side is equal to how much you got? It is
107.0 into 10 raised to 6.
100 into
Into 10 raised to 6.
10 raised to 6. 10 raised to 6. So unit it is mm cube. Okay. So same find out ZB. So for ZB section modulus for ZT now. Now we require find out the ZT means section modulus at top. So it will be I by YT. Okay. I by YT. YT means what? So for this one it is neutral axis of this wave. Okay. So YB it is from the, this one it is YB, okay, and remaining this portion it is YT top, okay. So now YB it is known, just find out the YT. I it is 7.04 into 10 raised to the cap 10 raised to 10, okay. So now how much YT, how much YT CL, total depth of beam it is 1200, 1200 minus 657.89, you'll get the YT. 1200 minus 657.89, so it will be 542.11. 542.11, okay. So this distance it is 542.11. So look at the ZT. Tell me how much ZT.
130.23 into 10 raised to 6.
ZT is equal to 67.89. Here one minute, just wait. So YT it is 300 plus 800 plus 200. Here actually total height it is 1300. 1300 minus 657.89. It will be 642. This value it is 642. This value it is 642. Here 300 plus 800 plus 200. It will be 1300. 1300 minus 657.89. It will be 642.11. Now tell me how much ZT.
109.63 into 10 raised to 6.
109, correct. 109.63 into the 10 to the power 6 mm, correct. Okay, now we will calculate ZT. Now load and moment calculate. First of all, calculate the self weight of beam. Next, we calculate this self weight of beam. Self weight of beam. Self weight of beam. So you can calculate self weight of beam. I explained in previous lecture also how to calculate self weight of beam. Cross sectional area of beam into 380. Cross sectional area of beam we have calculated. It is 380 into the 10 power 3 mm square. Okay, to convert it, it is mm square means 10 raised to the power 10 raised to the power minus 6 into unit weight of concrete. It is given here. It is 25 kilonewton per meter cube. You get the self weight of beam. This one. So just in some book it is denoted by mg. Okay, so we will write here WT, self weight of beam. So how much this one? 380 into 10 to the power 3 into 10 to the power minus 6 into 25. How much will get?
9.5.
Yes, it is 9.5 kilonewton per meter. Okay. And bending moment due to self weight. Bending moment due to self weight. Bending moment due to self weight. So MD is equal to WD divided by, it is formula bending moment when usual load act on that span. Anybody know? It is WD L square by 8, and it is simply supported. Okay, WD L square by 8. So WD it is WD is 9.5. WD it is 9.5, and span it is, span how much? Span of beam it is given. How much span of beam? It is 15 meter. 15 divided by 8. 15 square divided by 8. 15 square divided by 8. How much? Tell me now, MD. MD is equal to 9.5 into 15 square divided by 8. Bending moment due to self weight. How much this one? MD is equal to
267.18.
267.18 kilonewton meter. Okay. So now find out bending moment due to total load. Bending moment due to total load. Total load means it is W. W is equal to WD plus WL, means it is ply load. So dead load it is 9.5, and ply load it is given, means that is superimposed load, it is 13. So how much will we get? 9.5 plus 13. So it will be how much? 22.5 kilonewton per meter. This one it is total load on the span. Okay. So now bending moment due to total load, and out M is equal to, so you can write here, this one it is EMT, moment due to total load. Okay, T stand for total load. So it is WL square by 8. WL square by 8. WL square by 8. So W it is 22.5. 22.5. Span it is again 15 meter. 15 square divided by 8. Okay, 15 square divided by 8. So how much bending moment? MT. MT is equal to 22.5 into
632.81.
divided by 8. 632.81. This kilonewton meter. Okay.
At initial stage. Stresses at initial stage. Okay. Stresses at initial stage. So we'll write stresses at initial stage means what? It is pre-stress plus pre-stress plus self-weight. We consider pre-stress plus self-weight only. Okay. Pre-stress plus self-weight. Okay. So for that formula, sigma T is equal to top stresses. Here it is P by A, P by A, P by A. Stresses due to pre-stressing force. At the top it is tension. That's why it is P by at the top it is section modulus. We take here section, it is unsymmetrical. That's why we take section modulus, it is ZT. Then due to self weight, it is sagging type of bend occur. At the top it is compression. So it is movement due to self weight only we are considering. That is MD divided by ZT. Okay, divided by ZT. Okay. Okay. So first of all, we'll write sigma top. So pre-stress force, it is given in example. What is pre-stress force? It is given 1000 kilonewton. So convert it is in Newton. Convert it is in Newton. It is 1000 into 10 raised to 10 raised to 10 raised to 3. Okay, divided by cross-sectional area of beam. Cross-sectional area of beam. How much cross-sectional area of beam, student? Cross-sectional area of beam 380 into 10 raised to 3. Okay, 380 into 10 raised to 3. Okay, then next minus P into E. So pre-stress force again it is 1000 into 10 raised to the power 3. Intensity we have calculated. Student, it is 557.89. Correct? Divided by ZT. Section modulus at the top. Section modulus at top, how much? ZT 109.63. Yes, how much you got? Anybody of student? Yesterday we have calculated section modulus at top, ZT I by T. How much you got? Student? One not 6.63 into 10 raised to 6 mm3. Then next plus moment due to dead load. Moment due to dead load we are calculated. Moment due to dead load 267.18 into 10 raised to 6. So this one it is in kilonewton meter. So convert it is in Newton mm. Okay, so that's why 10 raised to 6 divided by again 1009.63 into the 10 raised to power 6. Okay, that. So now first find out first term P by A. So it is 1000 into the, otherwise you can directly get 1000 divided by 388. Okay, 10 raised to will get cancel. So it will be 2.63. Okay, so is equal to 2.63 minus next term 1000 into 10 raised to power 3 into 557.89 divided by 109.63 into the 10 raised to the power 6. So how much this one? 5.08, correct? 5.08. The next plus 10 raised to 6, both will be get cancelled. 267.18 divided by 109.63. So it will be 2.43, correct? .43. So final stress value will get how much? 2.63 minus 5.08 plus 2. So this one 2.43 na. 2.43 is equal to 2.43. So it will be get minus 0.02. Student, are you get same answer? Anybody have done calculation? Now sigma B is equal to so due to pre-stressing force at the bottom, it is in compression. So P by A, then plus P by ZB here. Here we can use here ZB, section modulus at the bottom, because the section it is unsymmetrical. Okay, then minus due to self weight of beam at the bottom, it is in tension. Which type of bend occurs due to self weight? Sagging type bend occurs. Okay, so ZB. Okay, ZB. Okay, so again write down so write down ZB is equal to P again 1000 into 10 raised to the power 3 divided by cross sectional area of beam 380 into 10 raised to the power 3. Okay, then plus PE 1000 into 10 raised to the power 3 into eccentricity is 557.89 mm. Now section modulus at the bottom means it is ZB. So how much ZB? Student, how much ZB? 107 into 10 raised to the power 6 mm cube. Okay. Then next, this one it is minus again MD by Z. So 267.18 into the 10 raised to power 6 divided by 107 into 10 raised to the power 6. Okay. So now tell me how much you will get this value. So this one we are already calculated, same value to be get 2.63. Okay. Then plus next 1000 into 10 raised to 3 into 557.89 divided by 107 into 10 raised to the 6. So it will be get 5.21. Okay. 5.21. So next minus next 267.18 into the 10 raised to 6 divided by 107 into 10 raised to the power 6. So it will be 2.49 minus 2.49. So how much final stress value at the bottom side? 2.63 plus 5.21 minus 2.49. So it will be 5.35. Everyone got same answer, student? Newton per mm square. This one. Okay. Student, have you got same answer? Anybody have done calculation? So this one it is sigma B is equal to 5.35 Newton per mm square. Okay, 5.35 Newton per mm square. Okay, Newton per mm square. Okay, so now we need to draw the stress diagram. Okay, so we'll draw the stress diagram at the top. So this one it is final stress diagram. First of all, you will draw the direct stress diagram. Okay, so I will draw here stress diagram. Okay, so this one it is cross section of beam. Okay, this one it is cross section of beam. Okay, this one it is cross section of beam. So first of all, stress due to pre-stressing, direct stress. So it will be 2.63. So this one it is 2.63. It is plus. Okay, at the top as well as at the bottom. Okay, so it will be P by A. So this value it is P by A from both side. It is same top as well as at the bottom. You got the same answer. Okay, that's why we'll get it is in rectangular shape. Are you getting my point, student? Okay, so this one it is neutral axis of this beam. Okay, this one it is neutral axis of this beam. Okay, see here. So due to pre-stressing force, just here, due to pre-stressing force, at the top it is tension. Okay, at the top it is tension, at the bottom it is in compression. Okay, see here this one it is minus, this one it is plus. Okay, so this one it is P by Z, P by Z, P by this one it is ZT. Are you visible, student, this one diagram? Student, P by ZB. Okay, this one ZB. So how much you got? P by ZT it is 5.08 and P by ZB it is 5.21. Okay, then next plus this one it is addition. Okay, so due to self weight at the top it is compression, at the top it is compression and bottom it is tension. Okay, so this one at the top it is compression, at the bottom it is tension. Okay, so this one it is MD by ZT, MD by ZT, and this one it is MD by ZB, MD by ZB. Okay, so you can draw the final stress diagram now. So addition of all these three diagrams, you'll get final stress diagram. At the top it is near about 0. Okay, so it will be at the top it is 0, at the bottom it is 5.35 plus 5.35. so this diagram you got, this one it is final diagram. Actually this one it is near about 0, minus 0.02 at the top stresses, at the bottom it is 5.35. Okay, so this one it is 5.35. Okay, at the top it is actually it is 0, near about 0. Okay, so this one it is final stress diagram. So first of all it is direct stress P by A, then plus at the top it is tension P by ZT, at the bottom it is compression P by ZP due to pre-stressing force. Okay, so hugging top type of bends occur, that's why at the top is tension, at the bottom it is compression. Due to self-weight, sagging type of bend occurs, at the top it is compression, at the bottom tension. So addition of all these stresses will get, at the top it is 0, at the bottom it is 5.35. So it is due to the initial stage. Initial stage means pre-stressing plus self-weight. Now in that second stage, now we will solve in second stage. Understood, student? Anybody have doubt here? Okay, nobody have doubt. Stresses at final stage. Second stresses at final stage. Stresses at final stage. Final stage. Okay. Here we consider pre-stress plus self-weight, then plus superimposed load or live load. Okay. Superimposed load or live load. Okay. These three things were considered here. Okay. Okay. So now right one second. Case 2. Case 2. Stresses at final stage. Stresses at final stage. Pre-stress plus self-weight plus pre-stress plus self-weight plus live load or superimposed load. Okay, live load or superimposed load. So for stage 1, so first of all we calculate sigma t is equal to here we are considering the loss ratio. In final stage we consider the loss ratio. So how much loss ratio is given in example? Take the loss ratio, it is 0.85 here, it is given in example. Okay, so for that we can just put here k, that is loss ratio. Otherwise you can multiply pre-stressing force to 0.85. Okay, point k p divided by a, then due to top minus kpe divided by zt, then plus here moment due to total loading we will take here. Okay, moment due to total loading, mt divided by zt, mt divided by zt. Okay, okay, okay. So kp loss ratio we know, loss ratio it is 0.85, loss ratio 0.85 into 1000 into 10 raised to the power 3 divided by cross sectional area of beam, it is 380 into 10 raised to 3, 10 raised to 3, then next minus it is 0.85 into it is 1000 into the 10 raised to the power 3 into eccentricity, it is 557.89, 557.89, then divided by z, so much zt, it is 109.63. 109.63 into the 10 raised to power 6. 10 raised to the power 6 mm cube. Then next plus movement due to total loading. Movement due to total loading. So how much movement due to total loading, student? Movement due to total loading. Two 67.18. So it is 632. 632.8. It is in kilonewton meter. So convert it is in Newton mm 10 raised to 6 divided by 109.63 into 10 raised to the power 6. Okay, mm cube. Calculate these values. Tell me, anybody have done calculation? Point 85 to the power divided by 380. It will be 2 minus 0.85 into 10 to the power into okay. So we'll get how much? Sigma top is equal to, first of all you got 2.23, then minus 4.32, then plus 3.33. So we'll get the final stress. It is sigma top is equal to how much? Sigma top is equal to 3.67 MPa. 3.67 MPa means Newton per mm square. MPa means it is Newton per mm square. Okay. Everyone now got same answer? Okay. Okay. So positive, it's got plus value means it is in compression. Okay. So now next find out sigma B is equal to 10 Kp divided by A, Kp divided by A, then minus a plus. So this one it is plus. At the bottom it is compression due to pre-stressing force. Plus Kpe divided by ZB, then minus MT, total moment due to total loading divided by ZB. Okay. So now you can write it. Okay, is equal to Kp, it is 0.85, pre-stressing force it is 1000 into 10 raised to the power 3 divided by 380 into 10 raised to the power 3, then plus loss ratio 0.85 into pre-stressing force 1000 into 10 raised to the power 3, eccentricity it is 557.89 mm divided by ZP. So how much ZB? Section modulus at bottom, it is 107 into the 10 raised to the power 6 mm3. Then minus moment due to total load, moment due to total load, it is 632 into the 10 raised to the power 6, it is Newton mm divided by 107 into the 10 raised to the power 6. Okay, 10 raised to the power 6. Tell me how much value this. First term it is 0.85, 1000 into 10 raised to 3 divided by 380. So it will be 2.23, same 2.23. Then plus 0.85, 1000 into 10 raised to 3, 557.89 divided by 107 into 10 raised to 6. So it will be 4.43. Then minus 632 into 10 raised to 6 divided by 107 into 10 raised to 6. It will be 2.49. 2.49 is equal to. So how much total stress it is? Sorry, this one it is 149 not minus 149 minus, it is minus 5.9 is equal to. So 2.23 plus 4.43 minus 5.59. sorry, 5 point. Sorry, 2.49 plus 3.41, 5.9, correct. 2.23 plus 4.43 minus 5.9. So it will be 0.76. 0.76 Newton per mm square. Newton per mm square or MPa. Okay. So just draw the stress diagram. You can draw direct final stress diagram. So sigma top it is 3.67. Sigma top it is 3.67. This one it is 3.67 and sigma bottom it is 0.76 sigma bottom. So this one it is final stress diagram. You can call this stress diagram it is 0.76. Okay. This one it will call final stress diagram. Stress diagram. Okay. Okay. Anybody have doubt here? Student? Anybody have doubt? Okay. So today we will stop here. Okay.